today is about diet modulation of progenitor cells, in some kinds of progenitor cells inside of bone marrow. So, as you know, stem cell in bone marrow, they can migrate from the bone marrow to the blood circulation, and they can, if they find some injury or some damage in some tissue, they can stop there and help in the regenerative process. If the cells don't find any injury, any damage, they simply go back to the bone marrow, and that which is the most attractive environment for a stem cell. So here we have in blue the control diet, they call ad libitum diet, and in red you can see the high fat diet, decrease lifespan, and high fat diet also is known by increased inflammatory process, and in green we have caloric restriction, increased lifespan, and caloric restriction as well known to decrease inflammatory process. The caloric restriction is well known to decrease fibrosis in tissue, and now high fat diet have been shown to increase fibrosis in several tissues. And caloric restriction also decrease inflammatory signaling, and high fat diet increase inflammatory signaling and have been shown to increase chemoattractive cytokines in several tissues. Here is a fat, but also in liver and heart. And so why is that? Because in injured tissues, damaged tissue, they need to bring stem cell to inflammatory cells to help the regenerative process. So they increase this kind of molecule. And but what if the inflammatory process during aging increase inside of bone marrow? What if the chemoattractive cytokines increase the expression inside the bone marrow? Well, there is some in vitro studies that not for several groups that show that increase, for example, SDF1, ICAM1, increase the retention of the stem cell in the stromal compartment, also increase the attachment of the stem cell in the stromal compartment. So the objective of this study was to analyze the bone marrow in several kinds, in different kinds of diets. Basically, it means different condition of inflammation. That's what I think. So the results we got is aging. So the frequency of a very small embryonic-like stem cell increase by aging. So we can see here in any kind of diet, we have increase by aging of this kind of stem cell. But in high-fat diets, the increase starts early in life. The frequency of hematopoietic stem cell was previously documented for several groups. In ad libitum group, in ad libitum animals, increased by aging, and so we got the same result. And in caloric restriction, we can see the tendency of increased hematopoietic stem cell here, but this number wasn't significant, and some groups have reported the same result. So in high fat, in our laboratory, the high fat diet group increased a lot of hematopoietic stem cell inside the bone marrow, and the increase starts much early in life. So it seems that as much as you eat, you have more inflammation, and maybe you have more retention of stem cell inside of bone marrow. So to check that, we analyze ICANN1 in the bone marrow. So let's just talk about mature bone marrow. I don't have time, so we can talk it later. But talking about from three months old, it's when the bone marrow is mature until the animal die. We can easily see the increase of ICANN1 inside the bone marrow. Either high-lipton diet or high-fat diet. I didn't analyze in caloric restriction, but we can see the environment of the bone marrow also increased inflammatory signaling. So we propose that in young animals, high-lipton caloric restriction animals, they have a normal mobilization. The stem cell can easily be mobilized from bone marrow to the blood, and these cells can help in the regenerative process in all tissues. And it could explain why young animals have easier regenerative process is better. So in old high-lipton animals and young and old high-fat diet animals, we propose that the increase of inflammation or chemoattractive signaling retain the stem cell in the bone marrow, so the stem cell cannot leave the bone marrow, and these cells cannot help in the regenerative process. It could explain why even in young high-fat diet animals the regenerative process is poor. And I would like to talk about some presentation we had here, but I don't have time, and so I jumped this. And in caloric restriction, old animals can keep the mobilization of some kinds of stem cell, at least some kinds of stem cell, to the blood, and these cells can help the regenerative process, or can help to migrate to a tissue-specific stem cell and renew this kind of stem cell in each tissue, so it can keep and it could explain why in old caloric restriction the regenerative process is still fine. So we propose that decrease of inflammation inside of bone marrow could make the cell be able to migrate from bone marrow to the blood circulation, and these cells could repair the tissues in all of the body. So I'd like to thank the investigative pathology team in Nagasaki University, mainly my supervisor, Dr. Isayo Shimokawa, and SENS Foundation, mainly Dr. Albert de Grey, Kelsey, Stewart, and Aaron, for all help to this presentation. Thank you.